Previously, we covered the core foundations. Now in part 5, we tackle Mercury, exploration and open questions. We've sent 2 spacecraft to Mercury. Between them, they've completely rewritten what we thought we knew about the planet closest to the Sun. But the more we've learned, the longer the list of things we still can't explain. Last episode, we looked at Mercury's strange magnetic field and what it might tell us about the planet's interior. Today we're closing out the series with a broader question. What do we actually know about Mercury? How do we find it out? And what are scientists still working to understand? Act 1. What we're dealing with, Mercury, is the smallest planet in the solar system and the closest to the Sun. At its nearest approach, it sits around 46 million kilometers away. At its furthest, that stretches to about 70 million kilometers. That difference matters. Mercury has one of the most elliptical orbits of any planet, so its distance from the Sun changes dramatically as it moves around. That orbit does something peculiar to Mercury's days and years. One full trip around the Sun takes 88 Earth days. But Mercury rotates very slowly. A single rotation takes about 59 Earth days. The result is a 3.2 spin-orbit resonance. Exactly 3 rotations for every 2 orbits. For a long time, astronomers thought Mercury kept one face permanently towards the Sun, the way our moon always faces Earth. Radar observations in the 1960s proved that wrong. Surface gravity runs at about 3.7 meters per second squared, roughly 38% of what you'd feel on Earth. And despite being the closest planet to the Sun, Mercury has extreme temperature swings. The sunlit surface can reach 430 degrees Celsius. The night side drops to minus 180. With almost no atmosphere, there's nothing to distribute that heat. What Mercury does have is an exosphere, an extremely thin envelope of atoms knocked loose from the surface by solar wind and micrometeoroids. Sodium, oxygen, hydrogen, helium. It doesn't protect the surface or retain any warmth. Calling it an atmosphere would be generous. Here's the open question I want you to hold on to. If Mercury is so close to the Sun, why does it have water ice? We'll come back to that. Act 2. How we explored it. Only 2 missions have ever visited Mercury. The first was Mariner 10, which flew past 3 times between March 1974 and March 1975. It mapped roughly 45% of the surface and confirmed the magnetic field, which was itself a surprise for a planet that small and that slow rotating. Then came a gap of more than 30 years before Messenger arrived. Launched in August 2004, it completed several flybys of Earth, Venus, and Mercury itself, before finally entering orbit on the 18th of March 2011. Over 4 years, it mapped the entire surface, measured the magnetic field, and studied the exosphere and interior in detail. On the 30th of April 2015, it ran out of propellant and impacted the surface, ending the mission. Messenger changed the picture significantly. It confirmed that Mercury's core is enormous relative to the planet's overall size, accounting for around 85% of the planet's radius. That's a higher core-to-planet ratio than anywhere else in the solar system. It also confirmed water ice, sitting in permanently shadowed craters near the poles, where sunlight never reaches and temperatures stay permanently below minus 170 degrees Celsius. That ice has likely been there for billions of years, possibly delivered by comets or asteroids. So, a planet baking in solar radiation, no real atmosphere, and yet, ice. That's not a contradiction. It's a reminder that conditions are local, not global. Act 3. Open questions. Even with everything Messenger returned, significant questions remain. The most fundamental is why Mercury's core is so large. One theory is that the outer layers were stripped away early in the solar system's history by a giant impact. Another is that intense solar radiation drove off lighter materials during formation. Neither explanation is fully settled, and the two aren't mutually exclusive. There's also the question of Mercury's geological history. MESSENGER found evidence of past volcanic activity, smooth plains, almost certainly laid down by ancient lava flows. But when that activity stopped, and what caused it to stop, remains unclear. The magnetic field is perhaps the most genuinely puzzling piece. Mercury has one, which it arguably shouldn't, given how slowly it rotates. Stranger still, the field is offset from the planet's center, stronger in the northern hemisphere than the southern. That asymmetry has no agreed explanation. The mission designed to address many of these questions is BepiColombo, a joint European Space Agency and JAXA mission launched in October 2018. Currently in cruise phase, it's using a series of gravity assists to slow down enough to enter Mercury orbit, with arrival expected in late 2026. It carries more instruments than MESSENGER and is specifically designed to study the interior, magnetic field, and surface composition in greater depth. Whatever it finds, it'll almost certainly raise further questions. That's consistently how Mercury has worked. Every answer so far has arrived with something nobody anticipated. Closer. Mercury is easy to underestimate. Small, airless, heavily cratered. But it holds information about the early solar system that no other planet can provide, because it formed so close to the Sun, under conditions that shaped it differently from everything else. We've visited it twice. We're about to visit again. And after 5 episodes, the honest summary is this. Mercury is better understood than it was 50 years ago, and considerably more puzzling than anyone expected it to be. Next episode looks at the question that connects Mercury's story to a much wider picture of how rocky planets form and survive. If you followed along from episode 1, the full playlist has everything in order, links in the description. If the series has been useful, subscribing is the straightforward way to catch what we put out next. No pressure either way. That is part 5 of Mercury. In part 6, we explore the next key question. Subscribe so you do not miss it.